Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Dogba Jr., your math tutor and also an instructor of mathematics at the University of Liberia. In my today's lesson, I will be looking at differential equations, and I'm going to be solving additional problem under differential equation. Particularly, I'm looking at a variable separable method. So we told you in previous lessons, when you have a differential equation and it's possible that you can separate the variables, thereby saying if you have, like say, variable x and variable y. So if you are capable of, you know, placing variable x on the left or the right hand side of the equation, and also variable y on one side of the equation, then it means that it's possible that you use variable separable method. Then you want to solve the general solution, you can just integrate both sides of the equations and find the general solution. So we've been using that method in our previous work examples. So we want to solve another problem, and the problem says if dy by dx is equal to e raised to the power x plus y, and it is given that for x is equal to 1, y is equal to 1. Find y when x is equal to minus 1. So it's a kind of very easy thing, right? So we take dy by dx equals to e raised to the power x plus y is the same as saying e raised to the power x times e raised to the power y, because when the bases are the same, we take one of the bases and just add the powers. The reason why we expanded this expression is because we have a power that has two different variables. So remember, our target is to separate the variable and apply variable separable method. So we can cross multiply dy by dx is just equal to, okay, let's cross multiply. It's just equal to e raised to the power x, e raised to the power y dx. So this is dx, so we don't need x, x power. Yeah, so we have to get rid of its e raised to the power y, e raised to the power y. So it goes out. So we send this e raised to the power y in the numerator, it becomes negative. And this side we have e raised to the power x dx. So in order for us to solve for y, we can now integrate both sides, or for us to find the general solution, let's integrate both sides. So the integral of e raised to the power minus y, remember, the integral of e raised to ax dx is just equal to 1 over e raised to ax plus some arbitrary constant c. So a represents minus 1 right here. So a represents minus 1. So we just have minus 1 over, let's say 1 over minus 1, right? And then e raised to power minus y equals the integral of, now the coefficient is 1, so it's just like saying 1 over 1 e raised to power x plus some arbitrary constant c. So we can multiply all sides by negative if we wish. So we will have e raised to power minus y equals negative e raised to power x. Now negative c is the same as saying c, so we just rewrite it as minus e raised to power x, just take plus a. Now we can further solve for y by bringing in some ln. So if we take the ln on both sides, we know that we're just going to have, we take the ln on this side, and then we take the ln on this side. So we take the ln on both sides. Ln of e raised to the power minus y is just equal to minus y. So ln of minus e raised to the power x plus a. So you like now you can divide both sides by minus. But we were told for x is equals to 1, y is equals to 1. So if we replace x equal to 1 y equals to 1, we can solve for the arbitrary constant a. So if this is 1, we have minus 1. X is also 1, so you have ln of minus e raised to minus 1, right? That's a positive 1, right? Plus e. So what happens? We have minus 1 equals to ln of minus e plus a. So if we want to solve for this guy in here, what do? We know that e raised to the ln of x is equal to x. So we can say e raised to minus 1, e raised to the ln of minus e plus a, so that we can be able to solve for what is in here. Therefore, e raised to minus 1 would just be minus e plus a, right? So just be minus e plus a. So how do we solve for a? We send this across. You have e raised to minus 1 plus e, all equals to a. So we have the value for a to be e raised to minus 1 plus e. Now the second condition says find y when x is equal to minus 1. So remember we saw for y, and then we got minus y equals to the ln of minus e raised to the power x plus a. But what is this a? This a is e raised to the power minus 1 plus e. That is a. E raised to the power minus 1 plus e. So now let's solve now. So we have minus y. So we can even decide to just multiply this whole thing by minus 1. So you have y to be equal to minus the ln of. Now look here now. So x, we also have x to be minus 1. So this one is minus 1. So what happens? E raised to minus 1, positive e raised to minus 1. So this is negative and positive. They go out. So we just have ln of e. What is ln of e? Ln of e. So know that ln of e is just equal to 1. So y will just be equal to minus 1. This is the value for y. This is how we solve, differential equations using variable separable method. It's just very, very easy. So please subscribe. Don't go. Subscribe. Please, 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 please subscribe. Like the video and hit our notification button so that you get updates on our new uploads. Thank you. See you in our next lecture.